Okay, lesson 77, consecutive odd and consecutive even integers, and then we're going to do fractions and decimal word problems. Now, if you got the hang of consecutive integer problems in the last lesson, this one is very similar, except this time we're going to do odd. We're going to do consecutive odd and consecutive even integers. So what that would mean, last time we did numbers like consecutive integers would be like 1, 2, 3, 4, 5. Well, if we did consecutive odd numbers, we would have 1, 3, 5. They would be consecutive odd numbers. Consecutive even numbers would be like 4, 6, 8. These are all odd, these are all even, and they're consecutive. The next one after 1, next odd number after 1 is 3. The next odd number after 3 is 5. So these are consecutive odd, these are consecutive even. Let's talk about, if we're going from 1 to 3, how many did you have to add to get from 1 to 3? If you're going from 1 to 3, we would add 2. If we're going from 3 to 5, we would add 2. So if the first number was n, to get to the next consecutive odd number, we would add 2. And if you look at the consecutive even numbers, if you go from 4 to 6, we add 2. And if you're going from 6 to 8, we add 2. So when we do the consecutive even and odd problems, we're always going to add 2 instead of 1. When we were doing consecutive integers, like if you're going from 4 to 5, you would just add 1. But when we're doing even or odd, we're going to add 2. If that doesn't make sense, let's try some examples. The first one says, find 3 consecutive even integers such that the sum of the first and second equals the sum of the third and negative 10. Really important with these is the first thing you want to do is set up your heading. So just like the last time, we're going to let n equal the first number. Now we're going to need 3 of them, so they're going to be consecutive even. So if we're going to go from 1 even to the next even, like if we're going from 4 to 6, we have to add 2. So our next one's going to be n plus 2 is our second consecutive even number. And if we're going to get a third one, we're going to have to add another 2. So it's going to be n plus 4 is our third consecutive even number. Tricky thing is when you do even or odd, the heading's going to be the same. To get from the first to the second to the third, you have to add 2 each time. That's the only difference from our lesson yesterday, so we're going to be adding 2. So let's follow along with the words. Find 3 consecutive even integers such that the sum of the first and the second, so we're going to add, it's the sum of the first and second. Sum means add, so the sum of the first and second is n plus 2 equals the sum of the third, so we'll get on here to third, sum of the third plus the negative 10, so we just do minus 10, plus the negative is just negative. So once we set these up, they're simple equations, so we're going to get 2n plus 2 equals n minus 6. Here you can practice kind of skipping a step. As much as I say don't skip a step, this is a step that you need to learn to skip. It looks really silly when you get old and you start having all these minus 2, and it just is unnecessary. You can do these things in your head. So I'm going to put all the n's on the left side, so that means I'm going to subtract n from this side. I'm going to subtract n from this side. 2n minus n is just n. And I'm going to bring the negative 2 over here, so I'm going to subtract 2 from this side. I'm going to subtract 2 from this side, so I'm going to get minus 8. So our first consecutive even integer is minus 8. So I'm going to put minus 8. Then I'm going to add 2. I'm going to get minus 6. Then I'm going to add 2 more. I'm going to actually add 4 to this one, or add 2 more to this one, and I get minus 4. So our consecutive even integers are minus 8, minus 6, and minus 4. Those are your answers. Let's try another one in case you didn't get that one. This one says find 3 consecutive odd integers such that the sum of the first and third is 7 greater than the second decreased by 18. That sounds really complicated until you do your heading and then just work your way through from left to right and put it in the equation. So we want 3 consecutive odd integers. So the first thing you do is you do your heading. You must have your heading. So n equals the first odd integer. So we're going from, say, from 1 to 3. So even if it's odd or even, you're going to add 2. N plus 2 is the second odd integer. Then n plus 4 equals the third odd integer. I know what's going to happen is when you hit odd, you're going to start wanting to do n plus 1, n plus 3. Even though you're going odd, you're still adding 2 to the numbers. Let's just review that. So say we have 7, 9, and 11. To get from 7 to 9, we're adding 2. From getting to 9 to 11, we're adding 2. From going from 7 to 11, we would add 4. So it's always going to be 2, even if it's even or odd. Alright, now we're going to follow along with the words. Find 3 consecutive odd integers such as the sum of the first and third. So here we go, first and third. So the sum. So the sum of the first and third is, that equals 7 greater. So we're going to put that over here. It's going to be 7 greater than the second decreased by 18. So here's the second, right here. The second, there's the second. We go over here. When we say second, we write what second is equal to. The second decreased by 18. Let's just make sure we got all this right. 3 consecutive odd integers such as the sum of the first and third. This is the first. This is the third. Is equal to, is 7 greater than the second, this is the second, decreased by 18. So let's just work this through. So we get 2n plus 4 equals n. Look at all these numbers we have to add here. So I'm going to add the positive ones. 2 and 7 is 9. Minus 18 will be minus 9. I'm going to take this n over here, so I'm subtracting an n from both sides, so we get n. And I'm going to subtract the 4 from both sides, so we get minus 13. So there we go. We have it. Make sure it's odd. If it says odd and you get an even number, you've definitely done something wrong. If you get a fraction, you've definitely done something wrong because it's asking for integers. So these are always going to be integers. And then we need to go find the other numbers. So if the first one is negative 13, so you can go right up to your heading and write the rest of the numbers. So we're going to add 2 to negative 13, so it's negative 11. Add 2, and we get negative 9. If you follow along with the words with these numbers, you should get an equal equation. You can always check these by following along with the numbers. Okay, let's try one more of these before we go on to the final type of problem. This one is find 4 consecutive odd integers such that the sum of the first and the fourth is 25 greater than the opposite of the third. So this time they want 4, so we're just going to take it one step further. We're going to have n equals the first, n plus 2 equals the second, n plus 4 equals the third, n plus 6 equals the fourth. Even though it's odd, we add 2 to get to the next odd number. Now we just follow along with the sum of the first and the fourth. So here's the first, n, plus the fourth. Way down here is the fourth. That's why your headings are so important. You can just go down here and look at your fourth. N plus 6 is, whatever it is right here, 25 greater. So we're going to add 25 onto there. This is very tricky, the next part. Then the opposite of the third. Well, here's the third. The opposite of third would be the opposite of n plus 4. The tricky part of this is you need parentheses. It's saying the opposite of both of these. If you don't have parentheses, the temptation is just to make the n negative, when really it's the opposite of both of these. Now we do our algebra. 2n plus 6 distribute minus n minus 4 plus 25. 2n plus 6 equals minus n plus 21. Then we're going to add an n to both sides, so we have 3n equals 27. I subtracted 6. I subtracted 6, so I'm not going to get 27, am I now? I'm going to get 15. And finally, I'm going to get n equals 5. So the first one would be 5. The second one would be 7. The next one would be 9, and then 11. So we can check this one. It says find 4 consecutive odd integers such as the sum of the first and the fourth. So the first and the fourth, that would be 16, is 25 greater than the opposite of the third. So the third would be 9, the opposite would be minus 9 plus 25. And we would get 16 equals 16, and so we got it right. Yay. Okay, the next one we're going to do is fraction and decimal word problems. These are very similar to percent problems, unfortunately. So let's give these a whirl. Maybe you'll find these a little bit easier. Lopez used a 5 iron, but the ball covered only 4/5 of the required distance. If she hit the ball 112 yards, what was the required distance? So right away, what don't we know? What are we looking for? That's what we're going to call x. So x is going to be the required distance. Required distance. We don't have much space here. Got it. Okay, so let's read it. The ball covered 4/5 of the required distance. If she hit the ball 112 yards, what was the required distance? So we're going to find 4/5 of x equals how far she hit the ball. So 4/5 of the required distance equals 112. So she had a distance that we don't know. This is the required distance. She hit it 4/5 of the way, and that distance, this part right here of the required distance, is 112. So we want to know what 4/5. We know that 4/5 of this whole distance is 112. So here's our fraction. So we're multiplying both sides by 5/4. We're multiplying both sides by the reciprocal. And I do not have my calculator with me. So we would take 4 and 112 and take it times 5, and we get the required distance equals 140. And it would be yards. You have to have units if there's units in your problem. So this one mainly is just using your common sense. What are you looking for? It says they hit the ball 4/5 the required distance, and they hit it 112. So that's how that's set up. Hopefully that all makes sense. If not, we'll go over some of these in class. Okay, the last one. 3/4 of the tickets had been sold, and there were 420 tickets left. How many tickets were printed? I'm not sure if the diagrams are helpful. In Algebra 2, we'll definitely use the diagrams. I think we can do it without the diagrams right now. It says 3/5 of the tickets have been sold. There are 400 tickets left. How many tickets were printed? So that's what we want to know. How many tickets were printed? So x equals tickets printed. Just let your variable equal what they're asking for. So 3/4 of the tickets have been sold. There were 420 tickets left. How many tickets total? How many tickets were total? So I'm just trying to think of how. So the tickets that were left are actually 1/4. Did I put the right thing? Am I right? How many tickets were printed? So it's actually 1/4 that were left. See how they're asking right here how many were left? This is why this one is tricky. It said 3/4 were sold. There were 420 tickets left. How many were printed? So we don't want to know. This is 3/4 were sold, so that means 1/4 were not sold. So we're going to actually take 1/4 times our x tells us how many tickets were printed. You know what? When we get in class, I'm going to draw diagrams for these. I think they're going to be helpful. I don't want to make this video any longer. So try these problems on your own. And if you have trouble, I'm going to show you how to do it with the diagrams, because eventually we're going to need to do the diagrams. So I'm multiplying both sides by the reciprocal, and then we get x equals 1,680 tickets. So hopefully you got the consecutive odd and even problems. Give these a try. But if you don't get these, we'll go over these in class in more detail. So that's it for lesson 77.